numbers, we need the derivative by the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom over bottom squared. So if I multiply that out, 8x minus 2x cubed. Add that out, I get a minus 8x minus 2x cubed. Distribute that minus sign. And we just lose the 2x cubes. Do you guys get this as your derivative? 8x. Oh, 16x, sorry. Divided by 4 minus x squared squared. Is that your derivative? Okay. So what is the critical number? X is 0. When you're checking for increasing and decreasing, make sure you also use as your cut points the critical number and the 2 vertical asymptotes. Yes.
You also want to set, like, what if when you set the bottom to 0, you get -2 and 2 as well?
Right. Use them as cut points. They're not going to be critical numbers because they're not even on the graph.
Okay.
But use them as cut points because the derivative could possibly change sign around them. So when you're going to check the sign of the derivative, we just keep the derivative right next to it. Draw dotted lines for your -2, so you know they can't be a max or min. But you break this up into intervals around those. So get the sign of the derivative. You tell me the direction of f. Pick numbers from these 4 intervals and plug them in there. It's quick to plug them in because you don't have to plug anything in the bottom. Bottom is a quantity that's squared. No matter what you put in there, it's going to be positive. So the sign of the derivative follows the sign of the numerator. So the derivative will be negative, negative, positive, positive. Is that the way you got it? The graph goes down, keeps going down, up, keeps going up. So I see my up arrows are between 0 and 2. And then again from 2 to infinity. Don't include 2 because it's an asymptote. So split up your interval. Decreases from minus infinity to -2 and from -2 to 0. You have a relative max? Nope. But we have a relative min at x is 0. Do you think that's enough to sketch the graph? You want to take another derivative. Go ahead so you can sketch the graph from there. If we need more information about the derivative, we'll get it, but I don't think we do. So it looks like what you think it would look like in between the two asymptotes. It's the minimum at 0. And when x is 0, y is 1. 0, 1 is a min. Then it decreases and then increases. So that's what it looks like between the asymptotes. To the left of -2, you've got to draw a graph that's decreasing. So if we go to the left of -2, there's no way it could be up here and decreasing. It's got to be down here. And so it's going to hug those two asymptotes. To the right of 2, it's got to increase. So again, there's no way it can be up here. In order to have the asymptotes, it's got to be down here and just mirror what's going on there. But when you look here, all my x's are squared. That should tell you you have an even function that's symmetric about the y-axis. Remember any of that stuff from the previous slide? So it doesn't look like we're going to have any inflection points, right, other than the asymptotes themselves. The second review would be so exciting. So I guess I'll show you guys the graph. That's what I determined the graph looks like.
How would you know to start on one again for the middle,
Say it again, please.
the middle parabola?
I just plotted a point. Put 0 in for x.
Oh, is that just like arbitrary? Or,
No, 0 was my critical number.
oh, right.
I like to plot my critical numbers if they're nice and easy to plot. All right, so let's see. Let me go back to section 4.3. Okay, so let's see. Quick calculation here. That's too hard. Hmm. Okay, I'm gonna do that one then. What's the sign of power 3? There we go. Okay, let's try this one. Let's hope it works. For the function f of x is equal to square root of 3 times the sine of x plus the cosine of x, show that x is equal to pi over 3 is a critical number. And then use the second derivative test to determine if that critical number is relative max or relative min. Quickly show that it's a critical number. And go straight to the second derivative test. That is from 4-3. to show something's a critical number, just show that it makes the first derivative equal to 0. Take the first derivative, plug it in for x, plug it in 0. This part will show that f prime pi thirds 0. And then here you're just going to determine the sign of f double prime at that point. Sign f double prime at pi thirds, and then make a decision.
Second test for like concavity, or
Well, if you know the concavity at the critical number, then you know whether the critical number is a max or min.
just plug it into the original one too.
I want you to do the second derivative test. That was supposed to be quick. First derivative is going to be the square root of 3 times the cosine of x minus the sine of x. Now I'm just going to plug in pi thirds. You get the square root of 3 cosine of pi thirds minus the sine of pi thirds. How's your trig? What's the cosine of pi thirds? 1/2. And the sine of pi thirds? So I have square root of 3 over 2 minus the square root of 3 over 2. So that's 0. That means it's a critical number. Now we're going to get the sign of the second derivative. So let's chunk out one more derivative here. Erase this and put it here.
So if there's a coefficient attached to a trig sign, then you don't take the derivative of that. So like meaning like you can take the derivative of root 3.
A derivative of a constant times a function is that constant times the derivative of the function. Let's pull constants out of derivatives and antiderivatives and then tack them on in the end. All right, so a second derivative. Again, I can hold that constant. Oops. The derivative of cosine of x is minus the sine of x. And then derivative minus sine of x is minus cosine of x. So now we're going to put in pi thirds. So the sine of pi thirds was square root of 3 over 2. Cosine of pi thirds is 1/2, but I've got a negative minus a negative. So that's going to be negative. It's a conclusion when the second derivative is negative. Relative max, right? Two negative signs, relative max. That good? All right, what about all of our limits? There's 3 for you. Come on, go to the west. There we go. There's the 3 limits I'm talking about. First one pretty quick. Get 0 on the first one. As the bottom grows, the numerator stays at 7,000. So it's bottom heavy. You can write this one almost in the same way. You write that with a positive exponent. Does that help any? What do you know about cosines? They bounce around between 1 and -1, don't they? So that's not going to grow. It's going to stay between 1 and -1, but the bottom's going to grow fast. So now that behaves just like this, right? Sorry? For sine and cosine, yeah. And then denominator goes to infinity, so that's going to go to 0. But this next one you can't just eyeball because this becomes infinitely large. This behaves like 0, sine of 0 is 0. To give you some manipulation on that one. Should get a limit of 1 for that third one. Nope, infinity times 0 is indeterminate. But you take it out of that form by doing what? Write it as a fraction. How? Divide by 1 over x. And now it has the form of 0 over 0, so you can knock out L'Hopital's rule. You have still the infinity times 0.
Remember how,
You want to get that x out of the way, because that's what's throwing us off. Yes, sir.
remember when we were first learning limits,
Uh-huh.
and you said we have those special case limits where you have sign, parentheses, something over the same something.
Mhm.
Did you do that same thing here as well?
That limit, that special limit occurs for x going to 0, so you have to do a change of variable. You would say let n be 1 over x. So as x goes to infinity, n goes to 0. And you have the sign of n over n.
Hmm.
That's one way to do it without L'Hopital's rule,
Oh, yeah.
right? You have to change it to the proper form. So as x goes to infinity, n is going to go to 0. So you can say that this looks like the limit as n goes to 0 of the sign of n over n. And now you could use that special limit. Okay. Or you can do L'Hopital's rule. You do L'Hopital's rule, it's just as easy. The derivative of a sine is a cosine. And then you have the derivative of 1 over x. That's going to cancel because there's a derivative of 1 over x downstairs. Those cancel. Take the limit as x goes to infinity and the cosine of 1 over x. You get the same thing. Cosine of 0 is 1. Okay. So we don't have to call it special limits anymore because we got a way of showing all the steps to get there. All right, let me write down a few more. Let everybody else look at those. There's two more right there. Starting with the one over here. So the first one's already set up for you to use L'Hopital's rule. Cosine of 0 is 1, sine of 0 is 0, so it has the form of 0 over 0. Let's see if you're good enough at simplifying and taking derivatives. Without some L'Hopital's rule to find that limit. Second one has the indeterminate form of 1 to the infinity. So you can do some more before you can do L'Hopital's. Cosine squared that. Sine cubed means this. So you've got the power rule and the derivative inside.
Change the 1 minus cosine squared x to sine squared x.
Oh, that'd be quick, wouldn't it? That's much quicker. Yeah, using the trig. Yeah, that's a lot easier. So what's your conclusion here?
Cool.
1/0, but that's not indeterminate. It's undefined. Right? All right, so you have to do L'Hopital's rule. I like that. All right, what's our plan of taking this one out of this indeterminate form? Use a logarithm. Set that equal to L, and take the natural log of both sides. That's in the next step, going to pull the power down. Got you started, now let's see, finish it. I didn't do what I wanted to do.
So after you the natural log, it turns into. After you take the natural log, it turns into form n times 0. 0.
Yes. We'll do the same thing with that x that we did with the last problem. So that we get it out of the infinity times 0 form. So multiply by x, divide by 1 over x. Just like we did in that other example. Now, that's the right form for L'Hopital's rule. What'd you get here? You get e to the negative 4? Now in this form, we're going to use L'Hopital's rule. The derivative of the log of u is 1 over u times the derivative inside. Think of this as 1 minus 4x to the negative 1, so that the derivative inside is 4x to the negative 2. Then when you take the derivative of this, think of that as x to the negative 1, so its derivative is negative x to the negative 2. The x to the negative 2's will cancel. And then I can take that minus sign upstairs to the 4. And like this now is the limit as x goes to infinity. That's going to be a negative 4 because of the minus sign. We'll move it over here on top. So 4 over infinity is going to go to 0. That means the denominator goes to 1. So the overall limit is minus 4. Since that was the natural log of the limit itself is e to the minus 4.
What's the one that wasn't negative 1?
I've got a minus sign down here that doesn't cancel and a 4 up here that doesn't cancel. This does. That cancels, so I'm left with a minus 4. And I'll put that up here.
Oh, it's one, basically minus 1 minus 0. Okay.
Right. Okay? All right, let's see if we can set up this word problem here. We're going to make our box with a square base, but this time we're going to put a top on it. We're going to make this in such a way that the 4 sides and the bottom is going to cost us $1 per square foot. So it's going to have a schmancy top that costs $5 per square foot. I'll give you a budget of $72, make me the biggest box. Biggest in terms of volume. Maximize the volume of a box, subject to cost constraints. So your objective function is volume, your side equation is cost. I'm gonna do the same kind of problem with a cylindrical container. Afraid you wouldn't know how to find the surface area of the cylinder, volume of the cylinder. Maximize volume. And our side equation is the cost. Cost depends on square feet. Call my square base x by x and the height y. Volume is just the product of those three. Cost is going to be $72. It's going to be the cost of the bottom. Plus the 4 sides. All of that is times $1. And that has to be areas, right? Plus, then you've got the top. And that's going to be multiplied by $5. Give me the area of those guys. Give Use that side equation maybe to get the y out of the volume equation.
On area plus 4 sides.
Yep. So make sure you're able to separate what it is that you want to take the derivative of and what it is that you want to write the side equation with. Get things going here. Side equation, the bottom has an area of x squared. Each side has an area of x times y. And then I'm multiplying that by $1. So pretend that that's multiplied by 1. And then the top has an area of x squared, and it's multiplied by 5. So let's solve this equation for y. 72 is equal to 6x squared plus 4xy. We have 72 minus 6x squared is 4xy. So then divide everything by 4x. Let me see how much I need to simplify that. Maybe none. Maybe let's plug it in for y and see what that simplifies to. We put it in here for y, and then gives you volume is equal to x squared times that. So I really don't need to do any simplifying because this x down here is going to cancel with one of those. So I'm going to have x times 72 minus 6x over 4.
6x squared.
Yes. So kind of ignore the 4, pull it out as a 1/4. Send the x through the parentheses. And now it looks easy to take the derivative of. Hold the 1/4 and take the derivative inside. You okay with that? And so our derivative. It's not a bad problem. It's an easy derivative. Root of 72x is 72. Root of 6x cubed is negative 18x squared. When I set that equal to 0, I find where 72 is equal to 18x squared. Let's see, 3 times 8. That goes 4 times. That's way nice of a problem. Gives us x is 2. And the second derivative is going to be negative, because I'm going to get a negative in there. So v double prime at 2 is less than 0, so that means I have a max. And so the dimensions of the box are going to be 2 feet by 2 feet. Now I'm going to go back over here and find y. Y is 72 minus 6x over 4. And so there's our y. Pretty nice problem, huh? So just pay attention when you're setting it up. What's going to go for your side equation? What's going to go for the thing you take the derivative of? And I think you'll be okay. What about in chapter 6? Basic antiderivatives, get all the formulas down. You know, you have to break up products. So the first one that was worked up here on Webwork was a good one. You had to divide things out and make it a sum. And then the inverse trig. What about all the trig ones? What's this one? That's a tangent. And then maybe to know what the C means, suppose f prime of x looks like 6 square root of x plus sine of x. Find f of x such that f at 0 is equal to 2. Can you do that? Given the derivative of a function, can you go backwards and find the function? And not just any function, one that passes through the order pair 0, 2.
I'm sorry, what is that? SPSE mean again?
Suppose, how about let? What would you do? Take the integral, get the antiderivative. So f is the antiderivative of that. I have to write that as x to the 1/2. So don't worry about the 6. Add 1 to the power, divide by the new power. And so this becomes x to the 3/2. What happens when you divide by 3/2? You get 2/3 right here. And what's the integral of sine of x? Minus cosine of x, and then you get a plus c. This will simplify. 3 goes in 6 twice. 2 times 2 is 4, so we get 4x to the 3/2 minus the cosine of x plus c. So we got the right derivative. Now we got to impose this condition on it. When x is 0, f of 0 is 2. We use that to find a particular value of c. So f at 0 is 2, gives us 2 is equal to 4 times 0 to the 3/2 minus cosine of 0 plus c. Cosine of 0 is? And 0 to 3/2 is 0. So that says c has to be 3. And now we have f of x to be this, where c is 3. Okay. With that. And then maybe the last problem is, can you approximate the area under a given curve with 4 rectangles and left endpoints? Write me out that something that whatever function. Then you're ready. Then you're ready. All good? Okay. See you Thursday, right in here for a test. Friday, that was close. I'm giving you a Thursday test.
Give me a
too.
heart.
You want to take my trig test on Thursday? I need somebody who can pass it. My
Actually,
trig
I don't know.
students can't. Sure.
So it's these things, it's just like,